Hello, welcome once again. Today discussing the fuel delivery system. We all know from the fuel tank, the fuel is delivered to the components called the fuel injectors, which are all the way in the front of the car. The fuel pump itself is in a fuel tank, as you can see. It's electric fuel pump. I think this pictorial describes it pretty good. That's why I chose this. So, a couple of components involved, but I wanted to stress the electrical part of it. Over here we have, in the tank itself, we have the electrical fuel pump. Now, as a result of that, we have fuel pressure. Fuel will be delivered through something called a fuel filter. Obviously, anything that goes into the engine cannot have any contaminants or dirt. So we have to avoid that. In order to do that, we have a fuel filter. Now, just like you have actually an air filter. So air and fuel which goes into the engine has to be clean. Now we have something called a fuel pressure gauge kit. So if you want to measure fuel pressure, you need a gauge to measure it correctly. Remember, this is fuel pressure, not voltage. Then it goes to the proper fuel injectors. If you have V6 or V8, 8 injectors, 6 injectors, they spray this mist with the proper fuel into each cylinder. Then there's a return line going back to the fuel tank. So we're going to stress one thing. A couple of things are missing. And in another video, I'll stress these other components like the fuel pressure regulator and all these things a little more. But now I want to delve into the electrical part of it so you understand better. An electric fuel pump is what it stresses. That whenever you hear the word electric fan, electric motor, think of one thing: a voltage. It needs a voltage. Electric fuel pump means, as soon as you hear the word electric, means it needs a voltage. What's missing in this diagram, this is just pointing out the actual fuel delivery. Okay? The electric part of it is not here, so I had to draw it in. Now, we need 12 volts to go to the fuel pump. In the olden days, there was a mechanical fuel pump, and the fuel pump was external on the outside. Now, it's in the tank itself, which is a hard place to get to, obviously. So as far as diagnostics, and if you have a crank and no start, it's hard to get to this point to diagnose. What you want to do is you want to go to the front. The front where the fuses are, where the relays are, is the most accessible that you can have access to. That's why in every video I always say, as you see, try to stay within that area. That doesn't mean that the problem is not the fuel pump itself, but we go to the areas that are the most easy to go to. Now, this fuse, this relay, this computer, which we'll discuss, is in the front, under the hood. But for demonstration purposes, I drew it over here. Now, as we said, we need 12 volts. Fine. We go through a fuse, let's say. One side of the fuse, the fuel pump relay fuse, will be 12 volts. The other one is 12 volts also, after the relay. Before the relay, we have 12 volts through a wire. We go over here. Now we have something called the relay. The relay needs sometimes a PCM, which is the main computer, to give the coil side, the control side, a ground. So one side of the coil has 12 volts, the other side has a ground coming from the PCM when the PCM decides to give it a ground. That will activate the relay. That will give 12 volts on the load side, which I didn't draw, to the electric pump, which we need 12 volts to. Now, there's a problem. Let's say you have a crank and no start. Do you measure fuel pressure? Let's say the fuel pressure gauge. I know many people don't have fuel pressure gauges, and number two, even if you have it, where are you going to put it? You're not going to have a Schrader valve, which is a valve specific to put the fuel pressure gauge. So Are you going to measure fuel pressure or you can measure voltage? Remember, the car doesn't start. Which comes first? Do I need the voltage to give me the fuel pressure, or do I need the fuel pressure to give me the voltage? So which comes first? So let's say there's a fuel pressure gauge, just like the gauge in your car for the temperature, for fuel, for anything. Okay, that's called a gauge. Now, first of all, how much pressure is needed? Depends on the system, depends on the car, depends on the fuel injection. Do you need 20 psi? Do you need 30? Do you need 40, 50? 50 psi is a good number. 55 psi is a good number. Some go as high as 60 psi. So, number one. Number two, make sure the pressure, if you are using a fuel pressure gauge, that it stays. It holds pressure. It does not drop from 50 and then goes down slowly over a couple of seconds. It goes down to from 50 to 48, 47, 46. You want it to hold pressure. What do we mean by that? Let's say you have a tire filled with air. Over time, it loses air. Why? Because there's a leak. Maybe in the valve stem, maybe in the tire itself, on the nail, right? It does not have air in it. You will lose tire pressure. How do you know? There's two ways of looking at your tire. Visually, or there's a tire pressure monitoring system that tells you, you know what? You have low tire pressure. So either visual or either electronic. If you put air into that tire, right? You see that it's underinflated and it doesn't take the air that you're putting in. Guess what? You know you have a bad leak. Can we see visually a fuel pump? No, that's the problem. We have an electric fuel pump. We can't determine if it's bad by visual. That's why the electronics is the challenge of how to diagnose if it's a bad fuel pump. And it's a costly venture, obviously. Not just you have to go to the fuel tank, which is probably full of gas and fuel when it happens. It is a labor and it is parts. And if the labor is 120 an hour, whatever it is, a 2-hour job, whatever, that's just $240 just for labor. Forget about the parts. Now, so again, in our example, the tire does not hold pressure because you keep on putting air in it and it does not hold air. It's a bad leak. Again, that was easy to see because the visual. This is not visual. I cannot go inside the tank and look if this is good or not good. So electronically, I'm left with, I have to measure it. Like we said before, do I measure fuel pressure? Do I measure voltage? The fuel pressure, let's say, is 0 psi. When I do put a pressure gauge, what's my next step? My next step is the voltage. I need 12 volts for this to give me fuel pressure. If I do not have 12 volts, I have no fuel pressure. I cannot deliver the fuel. So which comes first? The voltage comes first. But which do I test first? If you're able to use a fuel pressure gauge, this is the best test. Make sure you have fuel pressure and make sure you hold fuel pressure. Just like I gave you the example in the tire. If you need 32 psi in your tire, make sure it holds 32 psi. Now, so what are we left with? The fuse, the relay. One more thing that I had to draw in. What controls the relay? What activates the relay to give 12 volts to electric fuel pump? A PCM or the computer, the main one, giving it a ground on this side. We said we need 12 volts here, we need ground over here. The PCM will give it a ground. Now we have 12 volts. Okay, so basically now all of them worked the same way. It doesn't matter if the PCM gives a ground, if it has a physical ground. They all work the same way. It doesn't matter if it's Asian cars, domestic cars, European cars, whatever it is. They all have to work the same way. There could be one relay. There could be two relays like we had in, I believe it was Hondas. There could be 3 relays. You never know until you look at the wiring diagram. Okay? Now, diagnosing. Okay? Again, the fuel, I go to the fuse. I know I have a crank and no start, right? I go to the fuse, I measure 12 volts here, and I measure 12 volts over here. Does that mean I will have fuel pressure? Absolutely not. Absolutely not. Right? We still have this involved. Okay? Let's say you don't have a fuel pressure gauge. You don't know where to put it, and you don't have it. So we'll start from the voltage, like I just said. I got 12 volts here, 12 volts here. Does that mean that I have fuel pressure? Not necessarily. We're still left with this. I come to the relay, this side of the relay. I have 12 volts at the relay. Does that mean that I have fuel pressure? Not necessarily. I go to the other side, the fuel over here of the relay, not the coil side, the load side. And I measure 12 volts over here. So I say to myself, okay, fuse is good, this wire is good. What else? The main point to stress. If I have 12 volts coming out of the relay, what does that mean? The PCM gave it a ground. That means the computer is good. That means the coil side, this is the coil side, is also good. Why? Because it's been activated. Because I had 12 volts on the other side. That's a good thing. That shows me at least the computer is working. That shows me the relay is working. Will I have fuel pressure? Not necessarily. And you're going to say, but why don't I have fuel pressure? You just told me if I have 12 volts going here, that's a good sign, right? Let's say you just went to the gas station, went to BP, you filled up your tank with $40 worth of regular, right? Then you crank, you say, oh boy, I'm cranking, the car doesn't start, but I just filled up with gas, right? I just spent $40 at the gas pump, right? It doesn't matter. It doesn't matter if you put in super, premium, whatever, 93, 91, regular. It doesn't matter. It doesn't, the amount of gas that you have here in the tank, just because you filled it up, does not mean necessarily that the fuel pump will start. You need 12 volts and you need pressure. The fact that you just filled it up is nice. BP will tell you you're a good customer. Thank you for your service. But your car won't start. So, but if you are empty, obviously, then it will have an impact. So, over here, coming over here, 12 volts over here. I had 12 volts at the relay. My point over here is where do I have access to? Up to here. Easy to have access. Why? Because all this is in the front. Now comes the hard part. How do you get to the fuel tank, and how do you take it out? If you want to see a picture of it, this is a picture of the fuel pump itself, which is located in the fuel tank. So as you can see, you have to take it out of the fuel tank, and if there's a lot of gas in it, you need two people to take out the straps and all that. It's not that easy. So therefore, that's your last resort. So we chose to go over here because everything is easy under the hood. That's why in every video I always stress, go to the fuse, go to the relay. If I have 12 volts over here, that's a good sign. Like we just said, that means the computer gave this a ground. But there is a wire that goes from here to here all the way, because if this is here, which it is, there's a wire missing in this pictorial. The wiring has to go all the way from here to the trunk. What happens if this wire, which is represented from here to here, okay, is broken or corroded? So let's say I could have 12 volts at the relay, or I could have 0 volts over here. You don't know until you go to the actual connector of the fuel pump. That's a big problem, to go all the way from the hood to here. Remember, it's a long way, right? So that's why they're called harness wiring. So from the PCM, which is located over here in the hood, it goes to the relay. The relay box is in the fuse panel, obviously. Okay? And the wiring under the relay, which you can't see, obviously, will go to here. Right? Now, the problem exists. If I have 12 volts over here, do I have fuel pressure? Do I have fuel pressure on my gauge if I would put a fuel pressure? Absolutely not. Doesn't mean anything. What about if I get to this point and I measure 12 volts at the fuel pump, at the connector? Does that mean that I have fuel pressure? Absolutely not. Why? Because maybe the fuel pump is bad. When you have 12 volts at the fuel pump, if you're able to get to it, right? If you're able to get to this fuel pump to measure the connector, right? And I'm at 12 volts, guess what? The fuel pump is a problem. Because I went as far as I can. It delivered 12 volts to the fuel pump, which is what it's supposed to do, right? That means the relay is working. That means the fuse is good. That means the PCM gave it a ground. That means this wire from here to here is good. And everything up to this point is good. What am I left with? The fuel pump itself. And how expensive is that if you go to the dealer, right? There are many cheaper ones online, obviously. But, so, just because you have 12 volts over here doesn't mean you have fuel pressure. If the fuel pump is good, then you'll have fuel pressure with 12 volts. But why I drew a line to here is to isolate, to divide the troubleshooting. These are easy access, which are under the hood. But this, after that, is tough access. That's the last place, the last resort that you want to get to. Now, I hope you understand that. So first you have the 12 volts. That creates a fuel pump to activate it. Then you have fuel pressure in the line. Again, if you have 12 volts over here, anything could be a problem with the line, could be a problem with the fuel filter, could be a problem with the regulator, could be a problem with the check valve. Anything is possible. But we're doing our best just to make sure that we have 12 volts. Now, can you listen to it? Sometimes you can listen to it. Let's say I don't have a fuel pressure gauge and I just cycle the key. Like for GMs, you have to cycle it about 2 or 3 times back and forth, back in the run position to build up the fuel pressure. Sometimes you have to cycle it a couple of times. So therefore, the fuel pressure line over here, if we have 12 volts, we'll have fuel pressure. If we don't have 12 volts, forget about it. Forget about it. It's not going to be activated. This is the main line. That's why I stressed 17 minutes ago, I started with the statement. Electric fuel pump. What does electric? The word electric mean? It means it needs a voltage. We got to this point. Here's the voltage that it needs. Here's the voltage. Okay? Now, I received an email from someone who said, I made a video about a fuel pump. As you know, I made quite a few about fuel pump, how to measure the relay in the fuse panel itself, not taking it out, which, I don't believe in taking out the relays. And he said he watched my video about the fuel pump relay circuit, but he says he understands some diagrams, but it was a little complicated. He says it was on a high level. So he told me he had a problem after that. He went to the dealership. He had a problem, he thought, with a fuel pump. When the dealership diagnosed it, they found it wasn't the fuel pump. It was a wire going from the PCM to the relay. Somewhat like this. I'm not sure of the actual schematic, but from that you can infer that somehow a wire goes from the relay, which we drew over here, a ground, to the PCM. And he was happy about that, obviously. Much cheaper than changing a whole fuel pump, obviously. After that, he went back to the video, looked back at my video, and said, now I understand what you were talking about. I learned the hard way, but I understand the video, what you were trying to point out. You cannot assume all the time that it's a fuel pump, starter motor, battery. Like I tell people all the time, even the mechanics that I work with from 40 years, they're working with the basics that, you know what, this is a car from 25 years ago. It's not like that anymore. You don't have just starter motors. You just don't have ignition switches. You don't have Acuras. You don't see ignition switches. You have modules now. You have computers controlling a BCM controlling a PCM. You have sensors all over. You have airbags. You have radar units, radar detector units. Those go bad. You cannot always say it's a starter motor, it's a fuel pump. And a short story, and I'll finish. Like a person emailed me, and he said, I changed the starter motor. Right? I changed the starter motor, and it didn't do it. What do you think the problem is? And you know how many of those I get? So many I get of those. I changed the fuel pump, it didn't do it. I changed the start, I changed the battery, didn't. And I say, what's your data? What is your data for diagnosing that it was that Starman in the first place? Well, he said, I went to the fuse. I went to the fuse. The fuse was good. If the fuse was good, I was left with the starter motor. Had to be the starter motor. Obviously, it wasn't the starter motor. That's the waste of hard-earned money. Why? Because there's modules, PCMs, BCMs, like I just said. There are wiring, harness wiring in today's vehicles. It is much more advanced. That's why I stress the point. Sometimes people say that it's a little complicated what I'm teaching, but electronics is complicated. What makes it hard is this is not visual. This is not brakes. Like me and Scanner Danner, how we teach it, and he is a legend. He is just the best out there, Scanner Danner. But the way you teach electronics is not visual. Bad brakes, rotors, brakes, CV joints is visual. You can see that. You can see that the brake. You can see a leak. You can see bad brakes. You can like we just said. You can see a fuel line that's leaking. You can see all those things. They're visual. They're mechanical. You cannot see current flow. You cannot hear current flow. That's what makes it hard for me. Scanner Daniel does a good job trying to convey how do you teach people something that they cannot see visual, and that's electronics. The only way to see it is by a voltmeter, is by diagnostic equipment. That's the only proper way you can diagnose electronics. You cannot see a bad relay. I cannot see a bad fuse. You can look at it and it'll say, okay, it looks bad. I don't rely on that. I take a meter and I put an ohm meter and I measure the fuse. I don't rely if it's melted or not melted. I don't rely on hearing the relay. And that brings me to the point, sometimes, if you really want to do it, sometimes when you turn the key on, you hear the fuel pump being activated. You hear the 12 volts going to it. That's a good way of doing it, but that's not the best way. That's not the recommended way. That's not the best way to do it. So, as we said before, it is a little complicated, but electronics is complicated because the industry is making the automobiles more complicated. So therefore, we have to try to teach things, electronics, not electrical. 25 years ago, this is electronics, this is PCMs. We have to try to teach it the best we can. So sometimes for beginners, it'll be a little rough, but that's why I say go first to the other schematic. That's why I took a pictorial, drew it as easy as I can. No, you don't see no schematics here. It's just pure diagram, this, and what's going over here. But remember, if I have fuel pressure, that means I have 12 volts over here. This was activated. Is it correct fuel pressure? Is it 50? Is it 20? That's a different story. Am I holding the fuel pressure? That's a different story. But as far as the voltage, the electric part of it, is it done correct if I have fuel pressure? Yes, because I have 12 volts. If I don't have 12 volts, 0 PSI. If you put your fuel pump. So hopefully this made it a little simpler. Like I said, I'll go over the other things on different videos so you understand much better what these are. But I just wanted to give you a brief summary of the difference between fuel pressure and the voltage. First comes the voltage, turn on this, then as a result of that, you'll have fuel pressure. Okay? Anyway, please go to my channel, Joe Electronic Schematics for Auto. And my other one that I'm trying to get monetized, I need about 9,000 more minutes, is